Right now, if you're standing near the equator, you are moving at over 1,600 kilometers per hour, faster than a commercial jet, faster than the speed of sound. You can't feel it because everything around you, the ground, the air, the ocean, is moving at exactly the same speed. It's the planet's spin. Now, imagine that spin simply stopped. Not slowly, not over years. In one single second, you wouldn't get a slow, gentle stillness. You'd get one of the most violent events imaginable, and almost nothing alive would survive the first minute. Before we break the planet, it helps to understand why this spin is invisible to us in the first place. Earth completes one full rotation roughly every 24 hours. At the equator, where the planet is widest, that works out to a surface speed of about 1,670 kilometers per hour, or just over 1,000 miles per hour. That number drops the further you go from the equator. New York City moves at around 1,280 kilometers per hour. The poles barely move at all. Their rotational speed is close to zero. But here's the key physics concept. You don't feel constant speed, only changes in speed. Sit in a car cruising smoothly at 100 kilometers per hour, and your coffee doesn't spill. Slam the brakes, and it goes flying. Right now, you, the atmosphere, the oceans, and every building on Earth are all cruising together at the same rotational speed. Nothing spills because nothing is out of sync. A 1-second stop would be the equivalent of slamming the brakes on everything, everywhere, all at once. Let's slow this down to the first fraction of a second after the planet stops. You and everything not bolted directly into bedrock are still moving at your local rotational speed because of inertia, the same property that throws you forward in a car crash. Near the equator, that means your body is suddenly trying to continue moving at over 1,600 kilometers per hour, while the ground beneath you has just gone still. The result isn't dramatic, it's instant. Buildings would shear off their foundations, roads would rip apart at the surface. Anything not deeply anchored, vehicles, trees, people, would be hurled eastward at hurricane-shattering speeds, and it wouldn't just be solid objects. The atmosphere itself is also moving at that same rotational speed. Air doesn't stop just because the ground does, so in this same instant, the entire atmosphere keeps moving, creating winds far beyond anything in recorded history. Scientists who've modeled sudden-stop scenarios describe wind effects equivalent to several times the strength of the most powerful hurricane ever recorded. Not a storm, a planet-wide wall of moving air, scouring everything in its path. Solid ground and air are only part of the problem. Water behaves even more violently. Because Earth spins, its oceans currently bulge slightly outward at the equator, pulled by the same centrifugal effect that would fling you off a fast-spinning carousel. Right now, that bulge measures several kilometers higher than sea level at the poles. If the spin vanished in an instant, that centrifugal bulge would have nowhere to go but toward the poles, pulled there by gravity now acting without the spin to counter it. The result would be a redistribution of ocean water on a scale beyond any tsunami in human history. Entire coastlines reshaped, low-lying countries submerged, and inland areas suddenly under open ocean. Layer on top of that the existing momentum of every ocean current, every wave, every cubic kilometer of water still moving at rotational speed in the instant the spin stops, and you get a wall of water moving at hundreds of kilometers per hour, crashing across continents with no warning. This isn't a flood. It's the entire ocean trying to find a new equilibrium all at once. Assume, somehow, the planet survives this first cataclysmic second. What does the world look like in the aftermath? The most immediate, lasting change is the day itself. Without rotation, Earth would no longer cycle quickly between day and night. Instead, a single day would take an entire year to complete, matching Earth's orbit around the Sun. Half the planet would face roughly 6 months of continuous daylight, while the other half endured 6 months of darkness, much like the extreme seasons currently experienced only at the poles. Temperature extremes would follow. The sun-facing side would bake under constant exposure, while the dark side plunged toward extreme cold, similar to what we already see in polar winters, but now affecting the entire globe. There's also a deeper, slower threat. Many scientists believe Earth's protective magnetic field is generated, in part, by the rotation of molten material in its outer core, a process called the geodynamo. While the planet's rotation stopping wouldn't instantly switch off the magnetic field, a sustained loss of spin could, over time, weaken it. That field is what shields the planet from much of the sun's radiation. Without it, the surface would become increasingly exposed to solar particles and cosmic radiation. In short, the chaos of the first second would fade, but the planet it leaves behind would barely resemble the one we know. Here's the reassuring part. A sudden 1-second stop is not physically realistic. Earth's rotation carries an enormous amount of angular momentum, a property that resists sudden changes in spin, the same way a heavy flywheel resists being stopped by hand. To halt that momentum in 1 second would require a force so extreme that, in practice, it would likely require something like a direct massive impact, a collision on a scale that would already be destroying the planet through other means entirely. What does happen in reality is the opposite, an extremely slow, gradual deceleration. Earth's rotation actually is slowing down right now due to tidal friction caused mostly by the moon's gravity, which very gradually transfers some of Earth's rotational energy outward. The effect amounts to roughly 2 milliseconds added to the length of a day every century. At that rate, it would take many billions of years for any noticeable slowdown to occur, and the sun is expected to make Earth uninhabitable long before rotation becomes a serious problem. So, this thought experiment isn't a warning. It's a way of revealing just how much violent energy is quietly, invisibly built into something as ordinary as a normal day. Every single day, without you noticing, you are moving through space at speeds that would tear a city apart if they ever suddenly changed. The Earth doesn't ask your permission to carry you at over 1,000 miles an hour. It just does, quietly, smoothly, every day of your life. Stillness, it turns out, isn't the absence of motion. It's motion in perfect agreement. If you found this interesting, there's more like it coming. See you in the next one.